Hey folks, so happy to be here. Just had an amazing intro by Diwakar on what Clarity is all about. So what I'm going to do in this short developer session is show you how to build a basic contract on Stacks. So we're going to talk about NFTs because NFTs are a hot thing. So this presentation is titled NFTs on Bitcoin. That's a nice flashy intro to build an NFT that is written in Clarity and that settles on Bitcoin. So before, there's already a quick intro, but my name is Marvin Janssen. I'm the technical lead at the Stacks Foundation. So we're a nonprofit that tries to move forward the mission of the user-owned internet. Okay, so since Diwakar already kind of talked what Stacks is all about, I'll go over this just really quickly and then talk a little bit more about Clarity itself. So Stacks is, as we now know, a layer 1 blockchain that is connected to Bitcoin. So it uses Bitcoin for its finality, but Stacks itself is not merge mined or anything like that. It's truly its own mechanism with a novel consensus mechanism called proof of transfer. We have a smart contract language called Clarity, and Clarity has direct read access to the Bitcoin chain, which, as Diwakar just showed, leads to some very interesting things, like one of the community members that did a Bitcoin swap. Okay, so let's quickly go over some features, some properties of Clarity. So Clarity, as we already heard, is an interpreted language. It's not compiled. The reason for this is very simple. I would ask all of you the question, like, would you sign a contract you couldn't read? And by that, I'm talking about just any conventional contract. You go to the bank, you want to get a mortgage, they hand you a contract. Would you sign it if it's written in a language you can't read? I think for most people, the answer would be no. So the question then is, like, why would it be any different for smart contracts? Why would you interact and submit your tokens to a smart contract that you can't read, that's compiled into bytecode that's very difficult to analyze for its correctness, and that it doesn't have any hidden features that you don't know about? So Clarity is interpreted. The way you write the contract is exactly how it's going to be broadcast on chain and deployed. So Clarity is also decidable, non-turn complete. This gives us static analysis, so we know exactly what the most expensive execution path is going to be. Clarity also does not permit re-entrancy. So when Clarity was designed, it was basically just concluded that re-entrancy is really an anti-feature. What is a good reason to have the sort of re-entrancy that you've seen on different chains that leads to all sorts of exploits and things? You all know about it. So Clarity just not allow re-entrancy in any shape or form. So if this is attempted, then the transaction is automatically aborted. Clarity also does not allow underflows and overflows. So this will be detected on the language level, and if this happens, it automatically throws a runtime error and the transaction is reverted. Another feature of Clarity is that it has support for custom tokens built in. So custom tokens, I'm talking about your own fungible tokens, your own NFTs. This was pioneered on Ethereum, and Clarity thus has language support for these kinds of tokens. On Stacks as well, transactions are secured by post conditions. This was also briefly mentioned by Diwakar, but I'll talk about this in a little bit later as well. And a final feature that's very important is that responses from different function calls have to be checked. So, for example, you might all know the low-level features that Ethereum has to call into different contracts. So you can do a contract call, and then it will return a status code and possible return values, right? But it is possible to execute such a call in your contract and then forget to actually check the response. So you might trigger a token transfer of, say, an ERC 721, but you forget to check if it was actually successful, and then you update the balance or you do something else after that, and bad things happen. So in Clarity, if a contract call returns a response type, and this is an intermediary response, so this is not the response that your contract call is then returning, then you have to check it, and that means you have to handle it. So if it returns a positive value, so an OK, or if it returns an error, you got to deal with it. You cannot skip over it. If you try, then analysis of your contract is going to fail and you actually won't be able to deploy the contract. So if you still try, then the transaction is just rejected. Okay, so let's take a look at what it then takes to create a NFT in Clarity. And here is the built-in function call, define non-fungible token. You give it a specific asset name and an asset identifier type, and you've defined your own NFT. So it's that simple. Well, but of course, if you do it like this, then you have an NFT that cannot really do that much. So it's not quite that simple, but we'll take a look at how we can add some of the common features that you would expect with an NFT of this kind. So as I mentioned, Clarity has built-in functions to deal with all sorts of things related to custom tokens. So both fungible tokens and non-fungible tokens. So these functions right here, the first one, define non-fungible token, you pass it an asset name, which is of your own choice, and an identifier type. So usually this would take the form of an unsigned integer, but you could also choose any different kind of identifier type. So Clarity has a few built-in types, and next to unsigned integers, of course, there's signed integers. There's buffers, there's strings. So you could choose a different identifier type based on the type of NFT that you're building. So let's say that you're doing a decentralized name system, some application, you could choose to have an identifier type that is an ASCII string or a UTF-8 string, for example. And the other functions, NFT mint, you pass in the asset name, you pass in the token ID, which again, depending on that type, would be a uint or a string or something else, and a recipient. You have a NFT get owner, you again pass in the asset name and then token ID, and it'll give you back the owner, so which principal, so which address owns that particular token, and of course also NFT transfer and NFT burn. So the reason that these functions are built in is because Clarity tries to be very safe by design. So by using these functions, you already take care of a lot of things that as a new developer, you might not think of. So when you think about fungible tokens, maximum token supply, for example, you don't want to mint an NFT twice. You don't want to do a transfer of a token that a particular sender does not own. So all these side effects and these things are all covered by these built-in functions. So that's why you want to use these functions. So since these token functions are built in, it means that on stacks, tokens are first-class citizens. So if you mint an NFT or you mint fungible tokens, these are actually emit their own custom events, which is detected by, as you can see the Explorer here, this is a screenshot of minting one of these Staxies NFTs. And that makes it really easy to track what kind of different tokens users are holding, because it's all part of the asset maps, all the asset maps of that particular principal. So you don't have to query tons of different contracts to figure out what exactly a particular principal owns. You can just retrieve that from the asset information of that principal. So that makes it really powerful. Another upside to tokens being first-class citizen is the concept of post-conditions. So this is something that I haven't really seen in the same way on any different project before. But the idea is honestly quite simple, but very, very powerful. So imagine that there's a user, Alice, that is going to do a contract call to a particular NFT contract, right? So there's a contract call, the NFT contract then could mutate to chain state and does some particular things. So let's say that Alice calls into this contract, she calls the method transfer, and she wants to transfer a NFT with ID 1234 from transaction sender, so from herself to some different address. Then what she will attach to this transaction is a post condition that will basically state, after this transaction completes, I will have sent exactly one NFT of this type, my NFT, with this particular ID from myself to this different user. Then the transaction is broadcast onto the network, and the NFT contract performs some state changes, right? And tries to commit this to chain. Then what happens at the very end is that there's an additional post condition check by the node that will assert if that post condition that has been attached is actually fulfilled. So did the ownership of my NFT with that ID actually change from the transaction sender to this different address, SB123 and so forth? If that is the case, so if all the post conditions check out, then the changes are materialized on chain. If at the end those post conditions don't check out, then the transaction is reverted. And you can also then see this on the Explorer, that a transaction that would have otherwise succeeded was rolled back because one of these post condition checks failed. And I think that's a very powerful model, and it's made possible because tokens are first-class citizens on the Stacks chain. So I think it's very, very cool feature. When it comes to post conditions, you can get really creative with those. So you can turn on allow mode and then basically say like, well, whatever goes, I'm fine with it, which of course would open you up to possibly some security issues. You can set it to deny mode, and then you have to assert every single state change that's going to happen. So if you do a contract call that transfers an NFT, you transfer some other tokens, that all has to be part of these post conditions. Otherwise, it's not going to work. Okay, so what does a full-fledged NFT on Stacks look like then? So we have a standard called SIP9. It's kind of the ERC 721 on Stacks. And then on the right, you see what a basic SIP9 compliant NFT would look like. So there's a few functions in there that you've seen before. So we get a token, the last token ID. You can get a URL for a specific token. You can figure out who the owner is. You can transfer a token, and then there's an additional mint feature which is not part of the standard but added as a convenience, so we can see how all of that goes together. So we'll try this code out in a little bit and see how that works. So on Stacks, there is a composition model over inheritance, which means that in order to be compliant with a specific SIP that defines a token such as this, you have to implement a trade. And a trade is kind of like an interface would be in Solidity, right? So it defines the public interface of a particular contract. So which functions should there be, what should their input types be, and what should the output type be? All right, so let's just jump in. I'll switch to a code editor, and we can see what this all looks like. All right, so here is the same Stacksy's Clarinet file that I showed you on screen earlier. And we currently support a few different plugins for the Visual Studio Code editor. So if you want to do any Clarity development, this is really the best way to do it at this time. So I'll open up the console here. And we have a tool to develop and test Clarity contracts called Clarinet. And this is really the truffle of Stacks, if you will. So for those of you that know truffle and ganache, if you merge those two together, that's what Clarinet basically is. So it allows you to check your contracts for bugs. It allows you to run unit tests, which you write in TypeScript. And it also allows you to deploy contracts and define relationships between the different contracts that you're making. So if I type Clarinet check, it's going to analyze my contract, and since everything is okay, it's not going to say anything. But if I say make a change and I create an error here, right, it's going to analyze that and say that there's something wrong with this contract. Okay, so we'll try Clarinet in a bit. Let's first take a quick look at what this contract is all about. So we talked about these traits. So looking at this file right here, this is the trait that defines a SIP9 NFT. So as I said before, this defines the public interface to this contract. So any NFT that's compliant should have a function called getLastTokenID that takes no inputs and returns a response type. The second one, getTokenURI, you pass in a uint, so this is the token ID, and it returns a response with an optional string. So either you get the URL back or you get nothing. GetOwner, same idea, you pass in token ID, you get a response of who the owner would be, so that would be principal. And then we have a transfer function. You pass in the token ID, you pass in the sender, and you pass in the recipient. right? So this is the trade, very straightforward. Then in the actual contract here, you see that we reference this trade and we say that this contract implements this trade. This is very important because then static analysis can actually check if all these functions that you have conform to that trade. An interesting aspect as well is that you can reference trades that are already deployed on chain. So instead of having this local reference that I have right now, as you can see, this starts with a dot, which means this is a relative path, if you will, to a contract. I could also pass in a principal and refer to a trade that's been deployed before. So with this standard also comes an official deployment that if you're working on your own NFT, you would refer to that. Okay, then let's quickly go over this so you have an idea of what Clarity looks like and how it all goes together. So we define a couple of constants up here. So constants are defined when the contract is deployed. So you can actually pass in some parameters such as txSender, which means that once this contract is deployed, the contract owner constant is going to be equal to the address of whoever deployed this contract. Then we define a few constants with some error codes. So, only the owner can do some specific things. There might be a failure with token ID, and then you're not the token owner for if you're trying to do a transfer. So let's go down a little bit here and look at the interesting functions here. So the transfer function, you pass in a token ID, you pass in a sender, and you pass in a recipient. So it's very similar to what you'd see in ERC 721, right? We transfer from. The function is very simple. So it begins here, and there's an assertion that's being made where we check if the transaction sender is actually equal to the sender. Right. So obviously, this is a check to make sure that you don't transfer tokens that do not belong to you. So why do you have to do this check? So why doesn't NFT transfer do this check in itself? It's because like NFTs and fungible tokens, custom tokens that you build are really building blocks. So you have to define what ownership means and how you use these tokens, because we're using NFTs in the classic sense, if you will. It's funny to call like classic these days, but you could create NFTs that behave very differently and do different things. So you might have a different model of ownership here. So that's why you have to make that assertion yourself. So you check if the transaction sender is equal to this sender parameter, and if not, it will return this error value, which is just defined on U100. So this is something that you can choose arbitrarily. Then the second call obviously is the transfer. Okay, so let's take a quick look at mint. So this is a convenience function that I added that I will show you in a little bit. It just mints an NFT with the next ID to whatever recipient you pass into it. So this does something very simple. It just reads the current last token ID, which is a variable defined right here, which starts with an unsigned integer 0. So unsigned numbers always start with a U because Clarity is very explicit. You retrieve that token ID and you increment it by 1, following with an assertion that the transaction sender is the contract owner. So this convenience function can only be called by whoever deployed the contract. It will try to mint an NFT. And then it asserts that it can save the updated token ID in the next variable. So otherwise it's failed. So when would this fail? It's like when you really have a lot of tokens. And then finally, as a convenience, it also returns the token ID. So it returns an OK status. So let's unpack some of the things that are happening in this function here. You can see that this NFT mint is wrapped in a try statement. So I could take this off like this, but what we would have now is one of these, what we talked about before, these intermediary responses, because NFT mint returns a response type. So it's going to say either okay, it worked out, or error with an error value. And it does that based on some parameters. You can look that up in the documentation. Basically, if you mint a token ID that already exists, it's going to error out. So since it's an intermediary response, I have to deal with it. So what try basically does is it just asserts that it returns an OK response and will unwrap that response. So this will make that valid. Okay, so let's try out and see if we can mint one of these tokens here. So I'm going to open the terminal back up, make this a little bit bigger, and I'm going to type Clarinet console. So this starts a console session, much like, again, Truffle console. So what you can see right here is the output is that it shows me the different contracts that are deployed. So you can see the trade contract is deployed and my Staxys NFT is deployed, and Staxys has a bunch of public functions. It also initializes a bunch of balances, right? So that we can test out with that. What you notice right here, and this is something different on Stacks, is that a contract address is the address of the deployer, and then a dot, and then the name of the contract. So contracts are always named, and that's very useful, very easy to see what you're doing. Also, it provides a real distinction between what just standard principals are, so addresses that are backed by a private key, and contracts, right? It's very obvious, like obviously this is a contract, and then down here you can see all the different wallets. So let's try and do a contract call into that mint function right here. So I can type the extender, and you can see that right now I am the first wallet right here, which is the deployer right here, which is the same address that also deployed these contracts. So I can use shorthand notation to call into these contracts. So I say contract call dot Staxys mint, and I want to mint it to myself. So I say the extender. And you can see I get an OK1, and I also see that an event was emitted. So these are these first class events that I talked about earlier, NFT mint event, and it gives us some information about what actually was minted. So, you know, we can do this a couple of times, and I can mint a few NFTs for myself. And let's check contract call. I'm going to call the get owner function right here. Get owner, I pass in the token ID, for example, U3. And I should also pass in the contract name. That's Staxys right here, get owner U3, and yeah, you see that I get back the transaction sender. Okay, so I can also try and transfer this token to someone else. So I'm going to transfer token U3 from transaction sender to one of these different principals. So let's pick wallet number 8, because why not? Pass in wallet number 8, contract call. I get an OK true. So let's double check. And indeed, it has changed. Okay, so let's exit out of this. So what you can see is that it's very straightforward because of these built-in functions to build one of these conventional NFTs. It's very, very straightforward. And a lot of the safety mechanisms are already taken care of for you. So it's very nice. And of course, this is a very conventional NFT. So we've seen a lot of different NFTs that leverage the unique properties of the Stacks ecosystem. For example, there's a team called Boom. They make a wallet called Boom Wallet, and they created an NFT that actually generates a passive yield in Bitcoin because it leverages the proof of transfer consensus mechanism in a very unique way. So just by having this NFT, you just receive a Bitcoin as part of the consensus mechanism. Very, very fascinating. All right, so that was a really quick example of how to build an NFT smart contract that is then finalized on Bitcoin. So with that, I'd be curious to hear if there are any questions. I think we have a few minutes left.
Let me check and see the comments right here. See if we have questions for Marvin. John is asking if you want, are you trying to execute a smart contract on 2 or more related NFTs?
Where can I find these?
So they're a little hard to find. They're on the Hopin website on the side, so it's not part of this situation that we're on right here. So I'll have to relay them to you.
Got it. Yeah. If you could repeat that one, I'll try again.
So is it executing a smart contract on 2 or more related NFTs? Are you building 2 at once?
In this example, I was just building a single one. You can define multiple NFTs in a single contract, so that's definitely possible. But in this demo, I was just making a very basic NFT that I was just transferring to myself into different test wallets.
I've got a question here. What is reentrancy?
Oh, that's actually a great question. Naturally just skipped over that. So yeah, reentrancy is, I would say, like, I agree with the assessment of the developers of Clarity in that it is an anti-feature. So what reentrancy is basically you call into a contract, so let's say contract A, and this contract A calls into contract B. But then contract B calls back into contract A. So you create a bit of a loop. So they call that reentrancy, and this has led to the theft of lots of different tokens and other sorts of issues, especially on Ethereum. So a very basic example is that you have a contract that will keeps a balance and may transfer some specific token to you, right? Let's say it's like a vault or some sort of asset. So you call into this contract to withdraw your balance. And then what the contract does is it calls into the token contract, and the token contract is then supposed to update the balance. And then your vault will set the balance to 0. So looking at the chronology, so you call into the contract calls into that token externally, and then sets the balance to 0, and then returns. So what can happen is if this token is malicious in any way, then once that vault contract calls into that token contract, it immediately calls back into it and calls withdraw again. So before that, the vault could actually update its internal balance, you're calling withdraw again. And then you could possibly do it a few times, and then you can drain the vault without actually having that balance updated. So maybe you only had 10 tokens and the vault contained 1 million tokens, but because you keep doing this in the loop and the vault never actually gets the opportunity to update its internal balance, you can drain it. That's the basic idea of reentrancy. So this leads to a lot of different issues. In Clarity, if you make that call back into it, so it keeps track of this whole call graph, if contract A calls contract B, then contract B is not allowed to call back into contract A because we don't foresee any good reason why you would ever want a feature like that.
Great, thank you. I got a couple more questions here, so we'll just keep going. Cool. Matthew asks, you mentioned there are verifications performed by the compiler. Are there semantics for that specified for those somewhere in your documentation or somewhere?
Yes, but I do want to clarify one bit. So there's no compiler because Clarity is interpreted. So it will analyze the contract, and yes, there's specifications that check for that, which you can find on docs.stacks.co.
Marvin, Pete asks, Marvin, will there be a plugin available to integrate this with standard web like WordPress and such?
Great question. And since we were so focused on Clarity, we didn't actually talk about the front end side of things. But in Stacks, we have our equivalent to MetaMask, just called the web extension. So there's already a lot of apps that interface with smart contracts in the exact same way that you used to with other chain projects. So yes, we have the canonical libraries just called stacks.js. It can generate transactions, can interact with wallets, and give you that rich experience.
Hans asks if he wants, or if they want to learn Clarity, where should they start? And Matthew responds and says they found something at claritylang.org. Do you have a recommendation as well?
That's a great question, and that's actually how I wanted to end as well. So this is for all of you. If Clarity piqued your interest, and you can see how it's very different. It's a Lisp-like language. It's non-Turing complete, so it's decidable, which leads to all sorts of different properties. But if it piqued your interest, we are actually working on a project called Clarity Universe. So the Stacks Foundation is spearheading this educational project where anyone can join, and you can be a beginning developer, or you're just interested in developing, but you haven't done anything yet, or you're an experienced dev. We're going to launch 6-week cohorts that are free to join, and you can learn Clarity start to finish. We'll bring in all sorts of people to talk about it. You'll work on projects, and we'll also provide a pathway for you to get funding if you have an amazing idea. So De Walker mentioned the Stacks Accelerator. We have a lot of people in there, first cohort. We also have a grants program with the Stacks Foundation. So if you have an idea that moves forward, that user on the internet, come talk to us. And we can figure something out and give you the resources you need to build. So yeah, if you are interested, you should check out this link, Clarity Universe, and sign up for the waitlist. We're sending out something very, very soon.
Awesome. Matthew has a question, and I'm not going to ask it. I'm going to actually direct Matthew to get a hold of you in your Discords, in your Telegrams, in your comms channel, because it's a deep question, and this is a great place to stop. So where's the best place where people can get a hold of you? Let's say that again, just to make sure people catch it.
Yep. So if you want to join the official Discord for Stacks, it's literally you just in your browser type stacks.chat and you'll end up there. Otherwise, you'll be able to find it out. Go to stacks.co, go to stacks.org, and you'll find your way. So please do reach out, and we'd love to work with you.
All right. Thank you so much, Marvin. Really appreciate your time. Nice little back-to-back section on the Stacks ecosystem as we learn a lot more about you.